Hello students. Now in this video we are going to discuss a very important chapter, alternating current, all the NCERT exercise question. What you have to do that, you have to go through with this video and after that go through with the textbook and solve each and every questions. If you are getting any doubt, immediately prefer this video. This video will help you to understand the concept inside the numerator. But honestly I am talking about whatever the questions are there, you already, if you have the idea about the formula, if you have the idea about this particular chapter, then each and every questions, whatever they discuss in the chapters, are very easy. So let's start that. The first question is 7.1. A 100 ohm resistor is connected to a 220 volt, 50 HZ supply. Means one circuit is there, right? And that circuit have that some voltage, have that some resistance, as well as inside that one, whatever the current frequency is there, that is also the mentioned that. Now what that the question going to be asked, this one is the information. The first line is the information, right? What they are asking? Asking what is the RMS value of the current in the circuit. That is the first thing. Asking the virtual value of the current or RMS value of the current. Very good. Second question asking what is the net power consumed over the full cycle. Means in the circuit, in the resistance, when the current is going to be passed, then what the amount of the power going to consume by the resistor. So keep in mind that both the question is a formula based. So you must have to know the formula, then you can solve the questions. Concept is there, but the concept is not that much. What the importance of the formula in this question? So I will start this. So the first question, any kind of question, I already told you, first write the given. Okay, we are going to do that solution. So what is the given? Given is that R equal to 100 ohm. What the other thing is given? That is given EV. What is the amount? 220 volt. And as saying that a 50 HZ supply. So that is the frequency, 50 HZ supply is there. But for the first question, what is the RMS value of the current in the circuit? These two information is enough for us, right? So very simple thing is there, asking that IV equal to what? We are solving this one, the first question. IV equal to what? So what you have to do? IV equal to EV by R. The EMF provided in the circuit, that is the average, or you can say that this value is the RMS value of the EMF. So I will write the value here, 220 volt divided by 100 ohm resistance. Okay, when we going to divide this one, what the result I will get? It's a simple calculation, 2.2, and because the voltage and ohm giving the ampere, and that is the RMS value of this resistance, have this amount of the RMS value. That is also called the peak value, so not the peak value, sorry for that, virtual value, and it is represented by I. So this one is the answer of question number 1. Okay, so what is the important thing? That formula. You must have to know this formula. If you know the formula, this question is easier. Clear? Okay. Now come to the second question, question number B. Now what the B is saying, what is the net power consumed over a full cycle? Full cycle, you know that, like suppose circuit, try to understand, this is the circuit. Okay, this circuit have that AC EMF, voltage going to be supplied, R value is 100, ohm is given, right, and EV value, peak value is given, sorry, peak value not, RMS value is given 220 volt. Okay, and already just now we calculated by the help of equation number 1 the current going, alternating current, or you can say that RMS current is going, what the amount? 2.2 ampere. 2.2 ampere is the IV. Clear? This one is your IV. Now asking that what the power consumed. You know that the formula, very simple formula is there. It is a complete formula based question. Now what is the formula? Formula is there. Formula is P equal to EV into IV. Now put down the value. EV is 220 volt into IV is what? 2.2 ampere. Okay. When I am going to multiply this all, right? When I am going to multiply this, what the result will come? 484, and the power unit is watt. This one is the result. What exactly here we did? We removed the decimal, then 10 will come down, 0 to 0 cancel. I am going to multiply 22 into 22. Very simple. 2 2s are 4, and 2 2s are 4, 2 2s are 4. 4 4 8, and 2 2s are 4. So 484, and unit of the power is watt. So simple formula. So what I am talking about? This question is formula based. Okay? Understand? Okay, students. Now come to the second question. Second question also a very easy question and a complete formula based question. No doubt at all. The formula is going to develop by the concept, but this numerical you can easily solve if you know the formula. So we are going to go through with this question and try to solve that. You will get that the result with the help of formula. Now what the question is, the peak voltage of an AC supply is 300 volt. What is the RMS voltage? Okay, asking that what is the RMS voltage? That is the question number 8. The RMS value of current is an AC circuit is 10 ampere. What is the peak current? Means the very clear thing is that the first question is saying that if solution we are going to do. What the solution? Solution number A. What that saying that here in the question given that E0, because here mentioned that the peak voltage of an AC supply. So E0 is called the peak voltage or the maximum voltage. E0 equal to 300 volt is there, right? Now question is asking that what is the RMS voltage? Asking that EV equal to what? EV is the symbolic representation of ERMS. Okay. Now very simple is that the formula is saying that EV equal to E0 by root 2. This one is the formula. What you have to do? You have to put the value 300 in place of E0. That is called peak value or maximum value. 300 voltage divided by root under 2 have the value 1.414. Right? You just go for the division and you will get a result. And when you are going for dividing this one, what the result you are going to get? You are going to get 212.2 volt. Volt is the unit. If you go for dividing this, you will get this result. Okay, very easy. You can do this division by yourself. You will get this result. So this one is the solution number 1. Now, if we are going to come to the question number 2, that is our question number B. What is the question number B saying that? The RMS value of a current means IV is given of AC circuit is 10 ampere. That is a 10 ampere. Very clear? Okay. Asking that what is the peak current? Asking that I0 equal to what? Very simple. It is also the formula based question. What is the formula? Formula is saying IV equal to I0 by root 2. So I0 equal to IV into root 2. Put the value 10 into 10. First we are going to put the value 10 ampere into root 2. 10 ampere into root 2 value is 1.414. Okay. When you are going to multiply this, you will get the result. That result is what? 14.14, and the unit of this one is ampere. So both the question what you observe? Honestly, if you ask me, both the question, what is that? A very simple explanation is there. This question you can solve by using the formula. Okay? Now we are going to the third question of this chapter. What is the third question? It is saying that a 44 mH indicator is connected to 220 volt, 50 HZ AC supply. Determine the RMS value, okay, of the current in a circuit. Asking that what is the RMS value, means of what the RMS value of the current. So it's a very easier to solve this question. Why I am saying that it is a very easier? A small concept is there that I will explain you. But why I am saying that? It is also a formula based question. So come to that, what the given. Any kind of question we start with the given. What is that given? The first most important thing, this one. This one is the 44 mH, means it is the value of L. Now value of L is given 44 mH. Okay, I have to break this one. If I will break, this one is called Henry and this one is called micro. So 44 into 10 to the power minus 3 Henry will come. So that is the simplification of this one. Now come to that another, it is a inductor, okay. Now EV is given, what is that the EV? 220 volt, and a frequency is given, whatever the AC supply is there, they have the frequency, that is the F is given 50 Hz. We need this time this frequency. So these are the information is given and asking very simple question that what is the value of IV. So how we are going to calculate IV? We know that IV equal to what? IV equal to EV by XL. You know what is the XL? XL is inductive reactance. It is going to be counted as a resistance. So simple Ohm's law you know that, then I equal to EMF E by resistance. So XL is called inductive reactance. And if I will elaborate this formula, then EV is going to divide, XL is going to write omega into L. Okay? I will go to elaborate more this formula. I said that a small concept is there, only the formula you have to understand. What is that? EV and omega, we all know that 2 pi f. This one is the value of omega into L. Now everything is ready. You have to put the value, you will get the result. Now just I am going to put down the value. EV value is what? That is a 220 volt. Very good. Now come to that. What is the value? 2 into pi value is what is coming? Pi value is coming that 3.14, that you all know. And F frequency, here we already mentioned, that is a 50. Okay. Come to that, L value is mentioned into 44 into 10 to the power minus 3. Okay. That is the IV. What is that? It is our IV. That is called RMS value. That is called RMS value. And if you solve this one, you will get some result. Okay. That result, if you solve this one, I am writing directly. Okay. See, very simple thing is there. 220 volt is there, and whatever the formula is there, I just put it down the value. And once you put the value, you will get the result. That is a 15.92 ampere. You may ask that, sir, how you got this result directly? No, I solved this first. Okay, that is all the calculation, because the video length will increase. That's why I solved, and directly I am writing the value. That is a 15.92 ampere. Understand everyone? So see, again I am repeating this video. The question is very simple, asking that IV. In the question given value of inductor, okay, at the same time EV value is given and the frequency, whatever the frequency is going to use for the supply, and I know that the formula IV equal to EV by XL. From where you got that this formula? We got this formula by using the concept AC through a inductor. AC through a inductor, when we went through that, we got this formula. And by putting the value, all the values, we are getting a final result. Clear? So in this way you can go through with this question number 3. We will go for the next question now. Okay students, now we are coming to that another question. Question number is 7.4. Now this question also the formula based question, whatever the previous question number 3, it is same like that, only the small changes in the formula, but whole concept is the same. Now what is that? Asking that a 60 microfarad capacitor is connected to a 110 volt, 60 SZ AC supply is there, then determine the RMS value of the current. Again asking that determine the RMS value of the current. Right? Now this concept and the formula for this question, you will get the AC through the capacitor. Okay? So I will come to the solution. Very easy solution is there. Solution given. Any question going to start with the given? What is the given is that? Given is capacitor C value, capacitance of capacitor is 60 microfarad. We can write this one 60 into 10 to the power minus 6 F. Okay? Another thing is that the connected to a 110 volt. So EV is given, that is the 110 volt. Okay? 110 volt. And at the same time frequency also given, that is a 60 Hz. Okay? Now asking that what is the value of IV equal to what? Very simple. I will write the formula. If you have the idea or you know the formula, this question is very easy. IV equal to what? IV equal to EV by XC. Can anyone know that? What is the value of XC? XC is capacitor reactance. And we already know that XC value is 1 by omega into C. Remember that. That time also during the explanation we discussed this point. Okay? So that is the our X. Now come to the point, we will put this value here. What that? EV divided by 1 by what? Omega C. So what the result, new result will come mathematically? EV into omega into C. Okay? Now again elaborate this formula. So what we are getting? We are getting EV, okay, into omega 2 pi F into the C capacitors. Okay? So this one is the our formula. Now put the value. When we are putting the value, EV is mentioned that 110 volt. Very nice. Now frequency 2 into pi value is 3.14. F value is mentioned in exam question paper into the 60 in a question, not question paper. Okay, in a question mentioned that 60 and into C value is mentioned that 60 into 10 to the power minus 6. Okay, so this one is that the value you have to put. If you put this all the values, you will get a final result is 2. See that you understand, huh? Everyone. Yeah, how we put that? You can pause the video and you can go through this. Then what happened? You will get that. Yeah, how I put the value there. So after that you will get the result 2.49. What that? It is a IV ampere. You will get the result. You can go with the calculation of this value, you will get the result. So this one is that basically explanation of this particular question. So what I said, these all the questions are formula based. If you have that any confusion in a XC, then what you have to do? You have to go through the concept of AC through a capacitor. Once you go through this concept, you will easily get this answer. Okay? For any okay students. Now the question number 7.5, what they are asking there in exercise 7.3 and 7.4. Okay? In exercise 7.3, it's talk about to calculate the RMS value of a current in a what? In a inductor. Now question number 7.4 is asking about calculate the RMS value of a current when the capacitor is there. Okay, so keep in mind. So in exercise 7.3 and 7.4, what is the net power? Asking that either in an inductor and capacitor. Okay, so what is the net power absorbed by each circuit over a complete cycle, and explain your answer. Okay, it's a very easy question. If you ask me, both the questions have that the answer is 0. Net power absorbed in a AC circuit of the inductor is 0. Same way, the net power absorbed by the capacitor in a AC circuit is 0. That is the concept. Formula is there already in the explained also in the video, previous video. I already explained, you can go through that video also. So both the value is 0. But because of that, here one line is added, explain your answer. That's why we are going to explain this. So very simple explanation is there. What we have to write? Solution. We know that P equal to V into I. Power of any particular circuit going to absorb, it is going to depend upon the voltage and it going to depend upon current. It is a general formula. Now suppose if I am talking about any inductor, okay, this one is the inductor and it is going to get a AC supply. If you have the idea about this kind of circuit where the inductor is there and where we are going to provide the EMF, then one result is coming. What is the result? If E equal to E0, that is the instantaneous. E0 sine omega t is the EMF, alternating EMF in a circuit. At that time, after calculation, I equal to I0 sine omega t minus pi by 2 is coming. Keep in mind. Means the phase difference between the EMF and the current is that pi by 2, that is the 90 degree. So phase difference between these two are 90 degree. You have the idea about the graph, then what we are did that if this one is the phi and this one always this one is going to be t and this one going to be y. So what is that? It is a phasor diagram. Phasor diagram, this one is going to give a value of E0. So the value of I0 is coming like that. It is a phi minus 90 degree, or you can say that pi by 2. So what is the phase difference between these two? That is a 90 degree. That's why I said that here the current is lagging, okay, and EMF is coming 90 degree earlier, okay. So this one is the concept that already explained through the video. So come to that here, by using this, the new result will come. P equal to, what is the result will come? P equal to V into I cos phi. Okay? Means in the between the potential and current, the angle difference is going to be here, that is a phi. That is called phase difference. Now this phase difference is coming what? 90 degree. If you put the value of the cos 90, then what is the result will come? The result will come 0. So what is the explanation? And this one for inductor. So what is the explanation for 7.3? 7.3 purpose the explanation is the power equal to VI cos phi. The angle of phi is that a difference and difference between the voltage and the current in the circuit. That difference is coming 90 degree, that is a pi by 2. If I put this value of phi in place of phi, pi by 2, what the result we are getting? The total power absorbed by the inductor is a 0. Same thing we are going to observe in a capacitor also. Suppose one capacitor is there and going to connect with the AC supply. Okay. So when they are going to connect AC supply, you have that the idea. What the result is coming? E equal to E0 what? Sin omega t. And what the value of I we are getting? What the value of I? I equal to I0 sin omega t and plus pi by 2. Plus pi by 2. You have the idea? I will write here again. I equal to I0 sin omega t plus pi by 2. Okay? So, what we are observing again here, the phase difference between EMF and the current is 90 degree. So, we know that the power formula for the capacitor also, power absorbed by the capacitor, P equal to VI cos phi. What is the phi? Phi is the phase difference between the current as well as EMF. And that is what is that? 90 degree. Okay? It is coming half cycle earlier current. Okay? Because the current is leading in a capacitor. Okay? And in that inductor is a lagging. What the amount of lagging? So 90 degree is the lagging. Here amount of leading is 90 degree. So if you put the value of phi equal to 90 degree, again cos 90 is a 0. So power absorbed by the capacitor is 0. This one you have to explain. Okay. So when you write the answer now, what you have to do? You write this formula. And no need to draw the diagram and all. Just explain that AC through an inductor, there we are finding a phase difference between the EMF and the current is 90 degree. So when we are putting the phi value here 90 degree, we are observing that, or we are getting the calculation that power absorbed by the inductor is 0. The same thing we are going to observe in a capacitor. The P equal to VI cos phi, and the phi value is the angle differences between the voltage, that means EMF, and the current, and that differences is 90 degree. When we are putting this value, we are getting the result 0. So power absorbed by the inductor or maybe the capacitor in a circuit, what type of circuit? AC circuit, is always 0. So that you have to write in your words. If you write with this mathematical explanation along with your words, definitely you will get the complete answer in a question. So according to me, from the examination point of view, it is very important. Okay? Thank you. Okay students, now we are going to solve another question, 7.6. What the 7.6 is telling that to calculate what? The resonant frequency, that is omega r. You have to calculate, and in this question the information is given, inductance is given, capacitor given, and resistance is given. These three information is given. Not only that, one asking that what is the Q value of the circuit. In your mind it comes that what is the meaning of Q value? Q value is basically giving the magnifying voltage in the circuit. That we are going to discuss in that second portion of this question. The first we are going to calculate the value of solution. Value of what? Value of omega r equal to what? Okay. And in the question given, what is the given? Given L equal to 2.0 H Henry. Capacitor C equal to 32 into 10 to the power minus 6 Farad is given. And value of R is given, that is a 10 ohm. Okay, and you know that now what is the meaning of resonance frequency? The formula is there, Fr equal to 1 by 2 pi and root under L into C, inductor and capacitor. Okay, by when we talk about the LC circuit, the resonant frequency formula is this. If I will modify this formula, what I will get, 2 pi Fr equal to 1 by root under L into C. We know that the omega equal to 2 pi F, we know this one, that concept we know that the omega value. If I will write here R, then the frequency also R. So this one is asking here resonant frequency. In your mind may comes that, sir, the resonant frequency this one or this one? See, I am talking about the complete cycle, then we have to use this one. So question asking that omega R. So we are going to resolve this one because omega is the angular frequency. So this one is the formula, one step more. Omega R equal to 1 by root under L into C. Now put down the value. The value of L is 1 by root under 2 into, and what is the value of C? 32 into 10 to the power minus 6. If you put this value in that particular equation, you will get the result, and that is a 125 per second. You will get this result. Try to understand that. You will get this particular result. Okay. Okay. Now come to that a second part of the question. You understand this one? By using this formula, you will get the result of that. Now come to that the second portion. What is the Q value of the circuit? This one also a very easier to solve this one Q value. What we have to do that, the Q value actually I already said it is giving a magnifying voltage. So what is the formula of Q value? Q value equal to 1 by R root under L by C. If you go through this one is the formula, 1 by R root under L by C. That is the Q value. You put the value. Value of R is 1 by 10 ohm. Root under value of L is 2, and the value of C is 32 into 10 to the power minus 6. Okay, when you put this all the value, this one is the Henry and this one is the Farad. See that if you put the value of this resistance, inductor and all, and when you are going to solve this question, you will get that what? You will get that the sum result, that is a, if you resolve this question, then you will get a one result, that is a See, you may ask that any unit. Why I am not writing? Because the Q value don't have any unit. So that's why I am not writing the unit here. It is a complete number. So that's why if you resolve this, you will get the 25, the final value. So again I am asking. So again I am telling you the Q value is going to what, or it is mostly going to use for what purpose? It is going to use to magnifying purpose. How to increase the voltage inside the NCERT circuit. Okay? Thank you. We are going for the next question. Okay, now we are going to solve question number 7.7. This one is a very easy question. Just now we solved the previous question. There we use the formula. Question is a charge 30 microfarad capacitor. When capacitor is there, that is the charge, is connected with the 27 mH inductor. What is the angular frequency of free oscillation of the circuit? Very easy. Asking about solution we come to that directly the solution. Asking that omega r equal to what? Right? Through the resonance frequency, we know that. What we know? We know that. What we know? We know that if r equal to what? 1 by 2 pi root under L into C. That is the formula you know. If I will small changes to 2 pi fr equal to 1 by root under L into C. This one is come under the angular frequency. So omega equal to 1 by root under L into C. Okay. Now put the value of L and C, you will get the result. What is the value of L and C? This one C, and this one is the value of L. So I will directly taking from there. What is the value? 1 by C root under. First I will write L value 27 into, when we break this a small m, 10 to the power minus 3 into, if we write the capacitor 30, we break this micro, then 30 into 10 to the power minus 6 will come. If you put this all the value, go to the resolving this one, you will get that 1.1 into 10 to the power minus 3 and 10 to the power, we are getting here 10 to the power 3 radian per second. 3, because this one will go up, then it will be a plus. 10 to the power 3 radian per second. See the previous question also, right now, there also we have to write the, because this one is the omega r, so we have to write the, not the second, we have to write the radian second. So this one is the formula based question. You can directly use this formula and you can resolve. Okay, we will go for the next question now.